Hello, we're going to talk about correlation. Product moment correlation coefficient. Bloody good, aren't I? Aye.
Okay, that was my husband there doing the intro. Quite chuffed with himself, wasn't he? Don't worry, he's not doing the video. Okay, so what do we know about correlation? I think this is probably what you know so far. At GCSE, you learnt things had a positive correlation. So this is a scatter graph. This could be something like the number of hours you spend revising and your test score, couldn't it? So as the hours increases, the test score goes up. Negative correlation could be something like the age of a car and its value. So as the age of the car goes up, the value goes down. And no correlation could be something like, what about beauty and intelligence? Are they correlated? I don't know. You can argue that one out. Anyway, so beauty and intelligence. Right, so what you know so far is you know positive correlation, negative and no correlation. And you guys also have learnt to draw lines of best fit. Now, at the moment, I reckon if we look at this one, this positive correlation, we know it's positive and the crosses are fairly close to the straight line. So we would say it's fairly strong positive correlation as opposed to something that looks a bit like this, where the crosses were really kind of spread out and not at all close to the straight line. Now, what the product moment correlation coefficient does is it's a calculation that will calculate how good the correlation is. So how close the crosses are to our straight line. And it will give us a value between -1 and 1. So, for instance, if we took this example here, I think these crosses are fairly close to a straight line, so we would probably be calculating some sort of value roughly around about 0.9. So we would say roughly this looks around about 0.9. Now you're probably wondering, why am I writing the letter R? Well, thank God, product moment correlation coefficient is such a mouthful, isn't it, that actually sometimes it's shortened to R. Phew. So if I write R, I'm meaning PMCC. Okay, so that one looks about 0.9. It's positive. It's a positive number to show it's positive. This one here, if I was calculating this one's probably something around about 0.6. It's positive correlation, but the crosses aren't very close to a straight line. Now, negative correlation, this one here, that looks roughly around about -0.9, so that would kind of end up here. And no correlation, you've probably guessed it, is R equals 0. So that's that one, ka-chunk. Okay, now if R is 1, what it actually tells you is that your crosses are on a perfect straight line like so. Oh, doesn't look too perfect, but you know what I mean. And if R is coming out as -1, it tells you your crosses are on a perfect straight line like that. So this is perfect correlation, and this is perfect correlation, but of course one is positive and one is negative. Okay, let's see if we can actually calculate this product moment correlation coefficient, otherwise known as the PMCC or R. And here he is. Here's the calculation for him there. Now you're probably feeling a bit panicky, aren't you? Because you can see there's lots of horrible formulae on this page, but we're not going to panic. We're going to put the panic girl away. Okay, the first thing we're going to do is work backwards. So this R is calculated by this one first. That's SXY. There, and then we need an SXX on the bottom, and can you see there's this thing called SYY on the bottom as well. So there we go. So the R comes from 3 different things, SXY, SXX and SYY. And where do they come from? Well, they come from 6 different things. So if you look at the SXY, the first thing is the sum of XY. Have I got one of them? Yes, I have. Okay, so that's there. And have I got a sum of X? Yes, I've got a sum of X. And have I got a sum of Y? Yes, I've got a sum of Y. So those 3 things make up SXY. SXX is made up by the sum of X squared. There he is. And the sum of X, which I've already got, he's there. Oh, and I forgot to say N, didn't I? Sorry, there's an N also in there in both of the formulae. And SYY is made up of the sum of Y squared, so that's him. And the sum of Y, he's there, and there's an N. Okay, so 6 things giving 3 things, giving 1 thing. So what we'll do is we'll work backwards. We'll put that all in the bowl. Some of it seems to go in the bowl and some of it goes on the top of the bowl. Who knows why? So we'll put all of those in and we'll work with these 6 things first. Okay, we're going to call the English marks X, ka-chunk, and the maths marks Y. And we're going to need a table. Here comes my table. And the first thing we're going to do is we are going to find the sum of X. Right, I'm just going to move this along here. Right, the sum of X, there he is. The sum of X is coming in at, with a calculator, it's coming in as 619. Okay, the next thing we can do is the sum of Y. That's the next easy bit, isn't it? And the sum of Y, if we add all of those up, is coming to 22. Right, we also need the sum of X squared. So let's do the X squared column. Now this gets rather large. 11025. That's 105 squared. 100 squared is obviously 10,000. 108 squared is 11664. 100 is 100,000. Not 100,000, 10,000. 102 squared is 10404. And 104 squared is 10816. So if we now sum all of those, it will be rather large, but the sum of X squared is coming in as 63,909. Okay, we're also going to need a Y squared column. The Y's are a bit easier, aren't they? 5 squared is 25, is 4, 8 is squared is 64, 1, 4 and 16. Oh, make that look like a 16. And the Y squared column, let's put him in. The Y squared column is when we sum it 114. And the last column we're going to need is a column with an XY. So 5 times 105 is 525. And 2 times 100 is 200. You got the hang of it. And 8 times 108 is 864. That doesn't look like a 6. And 100 times 100, sorry, 1 times 100 is 100. 2 times 102 is 204. And 4 times 104 is 416. And therefore my X, sum of XY is, when I add all of that up, it's 2309. And the only one that I'm left with is N. Now, N is often the one that people sort of get a bit lost with. N is actually really easy. It's just how many numbers I've got. So I've got 1, 2, 3, 4, 5, 6. So N is 6. Okay. Right, on to the next bit. We're going to have to get these out of the bowl. So, in fact, my bowl's getting a bit messy, isn't it? Let's move some of this out. So I reckon I'm going to need him and him. And I'm going to need him. Okay. Right, let's make that a bit smaller. So, I'm going to need some more space, aren't I? Let's go on to the next slide. Okay, so let's work all of these out. So let's first of all do SXX. And then we'll do SYY. And then lastly, we'll do SXY. Okay, so SXX is the sum of X squared. Where's that? 63909. 63909. Minus the sum of X, that's there, so that's in the bracket, so 619 in the bracket. Notice it's just that that's squared, divided by N, which is 6. Okay, if you put all of that into your calculator will give you 293 divided by 6. Now, often you would then give that as a decimal in the exam papers, but I'm just going to leave it as a fraction to begin with. Okay, let's do the next one, SYY. So SYY is found by the sum of Y squared, where's that? 114, minus the sum of Y, that's 22, so it's 22 squared divided it's by 6. Okay, so that gives me, SYY gives me 100 over 3, and again you should probably give it as a decimal. SXY is the sum of XY, which is 2309, minus the sum of X, where's that? That's there, 619. Now notice these two things are timesing, so it's times by the sum of Y, which is 22, all over N, which of course is 6, and I am getting that out as 118 over 3, which again you should give as a decimal. Okay, I've moved them over so that I can get the big beast out. Here he is. That's my calculation for R. So, jumping around a bit. Don't jump around, stay there. Okay, so R is calculated by SXY. Where is he? 118 over 3. 118 over 3 divided by the square root of SXX. Where's he? 293 over 6 times. Now notice these are sat next to each other, so they're actually timesing SYY, which is 100 over 3. Be really careful how you put this into your calculator. I went wrong actually the first time I plonked it in. So I tended to do this bit first and then do this bit divided by this bit. But your calculator should give you 0.9749070014, which to 3 significant figures is 0.97. Okay. So the last thing we have to do is we have to make a comment on this R coming out as 0.97. So there's a couple of things to say. The first thing we say is we notice it's positive. So we say as R is positive and close to 1, there is a strong positive correlation. All right, we recognise that. It's a positive number and it's pretty close to 1. Okay, here is what the scatter graph looks like. So I think our correlation is actually pretty good, isn't it? You can see that. Look, these crosses are fairly on a straight line. Okay, so a correlation of about 0.9 looks about right. Okay, here's one for you to try. You see if you can find the product moment correlation coefficient of this. I've just given you 4 values so that it won't take you ages. All right, pause the video, have a go, and then check your answers. Okay, here are the answers. Did you get it right? It's kind of up here. It got lost in the scatter graph. R comes out as minus 0.989. And here's the scatter graph. You can see that those crosses are fairly close, aren't they, to a straight line? And here's your comment. All right, as the maths marks increase, the English marks decrease. So as the maths marks go up, the English marks are going down. And R is negative and close to 1, showing a strong negative correlation.